Okay, thank you, Brandon, Professor Ogata, and our distinguished guest. I'm Stephen Yang from National Central University. Today I'm going to put 5 case studies throughout my talk to cover 2 parts. The first one is analyze students' learning activities. And second part will be the prediction of students' academic performance. So let's begin with the study 1. We do data collection and the dashboard for students doing a Python programming course to collect their coding activities. When students interact with the university, or especially for the learning management system, they will have lots of digital footprint left. So we can get data, tracking logs from the ebook reading, like a book roll, okay, video, like a MOOCs. We even can get a science and experiment. And this one will be focused on the coding activities. This is the environment for our Python. We use Jupyter. This is the screen. And we do the collection through students' hands-on training, exercise. So we collect the log, do the filtering and re-extractions, then put it in the visualization. Sometimes we have more than dozens of activities interest. In our experiment, we just focus 9 of them. For example, the time spent on coding, the number of fail, types of error code. So this is the corresponding dashboard for the previous 9 activities. We can also take individual to have a look at this. For example, this is the type of coding errors and error distribution for a class. So we continue work on this study. We do the automatic detection of students' coding style and their code defects. We utilize NASA's data set because we are doing Pythons, so we need to do the transfer learning. And the algorithm we use is the DANN, is a domain adversarial neural network to identify students' coding defect and their relationship with the coding styles. We're also interested in finding out the correlation of students' self-regulated learning strategies and their final performance. Here is the case study 2. We are interested in finding out the critical factor affecting students' academic performance in MOOCs. This is part of an empirical study in Taiwan. We have national projects, is the Taiwan Digital Learning Initiatives, when I serve at the Ministry of Education. And part of it is the Taiwan MOOCs initiatives. These initiatives mainly funding university in Taiwan for university to develop MOOCs courseware and the mechanisms, and also for the data analytics. So I only show you part of them. And our initiative use our official platform is Open edX. It's based on MIT edX. We don't use Coursera because Coursera, you need to assign agreement with Coursera. But edX has a public open source. And the good thing is we can use Insight to take the tracking log and do further analytics. The data lasts for 3 years, and this is the course number. Well, in Taiwan is a small country, so 590 around 60 is a huge number to Taiwan. And we select the top 10 courses out of the 590 courses in terms of registers. The number is relatively low compared with other, because these courses are mainly in Chinese. I think in Japan it's the same, right? If pure in local language, then the registration or enrollment in general won't be huge. So we use another index. We put a number of activities per registers. Then in this case, for this class 101, this course, they have a high activity per register. So we use this course for our data analytics. This course is happened to be offered by my university. So we work very close with our lecturer. And it is right now the most active course. We use a blended learning not too much students, only 59 students. And the good thing is we know their grade. When we face MOOCs, most of the time we don't know a student's grade. But this one, because it's a blended, so we know student's grade. Here is what we are interested. We use two algorithms. MCA to find out the correlation of students' activities and their final grade. In MOOCs, there are two: video viewing and exercise practice are the most active activities. And we use MFA to find out critical factors affecting students' grade. Here is the MCA. I skip all the math behind the graph. So when we're reading this MCA for the right hand and lower corners means is negative. So all the red dots are activities for video viewing. Blue dots are their grade. So this means less video viewing activities, lower grade. And for this part is more activity resulting in high grade. This is for exercise practice, is similar to the previous one. And this one is find out their factors. So for this low grade, the blue line means it's highly related to students whose grade is low. And for this green line is highly related to students with high grade. So let's put it in English. It will be easier to understand. The correlation of students' MOOCs activities. Take video viewing. It is the critical factor resulting in low grade. And exercise practice is the critical factor resulting in high grade. So our next research question is, what kind of viewing activity resulting in low grade? And we try to help students whose grade is low. So let's further classify viewing activity into 4 and find out their critical factors, how to help students improve their grade from low to middle, and also from middle to high. We use the same graph. So here, for this low grade GPA 1, the green one and the blue one are highly related. For this GPA 3, red one is highly related. And for this grade 4, red one is also highly related. So again, we put it in English. So what factor affecting low grade? We found, G2 and G3 are the critical factor resulting in low. What is G2 and G3 is the first time watch and video viewing frequencies. So our suggestion is, in order to improve students from low to middle, students need to watch video early and increase video frequency. And this is for middle grade. The critical factor is G4. G4 is complete the video viewing. So our suggestion is, in order to improve grade from middle to high, students should complete the video viewing as much as possible. Here is the work. We are continual work. It also is part of institutional research in my universities. We would like to compare students' high school performance between their college performance, especially for freshman years. We also would like to know the types of entrance channel, how it related to students' freshman years. In Taiwan, we have kinds of entrance channel. You can enter by exam or by application, just like the States. So we would like to know which affect the most. And also we would like to know, for those students who pass entrance exam, which subject is most related to their freshman year's performance. Surprisingly, to a computer science, math is not the highly related. Instead, it is English, and then Mandarin, and then science, and then, no, math is not a critical factors. But it probably, for some reasons, in Taiwan, Jiha asked, what is a national university? In general, it means the students entry with higher standards. So most of them, their science and math are good enough. So the differential is language. So that tells us how important language is, especially English. here comes to the study 3. We do visual analysis of viewing patterns. This is still part of our initiatives. We have lots of graphs for the visualization. For these viewing events such as a play, pause, forward, things like that, we can have a hit graph. So from here, less dark means less viewing, means less attention. In contrast, for more dark means more viewing and more attention. We also have another kind of grade. We call it a peak graph, which means for a particular video, for some period of time, it attract a lot of attention. Here we have a lot of attention. So it could be a hint for instructors or for students to put bookmark or put index there for better search in the later on. This diagram shows the viewing sequence. For example, for a student, you can play, move back, play again, move back, play, so on and so forth. The red one is move forward. So we can track the viewing sequence of students. This graph a little bit complicated. You know, in MOOCs, the serious problem is the low completion rate. So we try to improve this by how to help students who not complete the course. So take this video, for example. When most of the students, this is backward. So when there is a high density of backward, that means there must be something interesting. And for the students who not complete the course, they are the major result of this. And also students who complete the course have the same thing. So it probably due to the material is too difficult. So for all the students, they involve lots of backward because they need to read again and again. Take another, for example, if the 3 areas of backward mainly result by students who not complete the course. So for instructors, they know the students who not complete the course probably struggle here. So we can identify those students and identify the particular areas, try to provide timely intervention in order to improve the completion rate. So we further would like to find the correlation of viewing pattern. We say viewing event, viewing sequence, now comes to viewing patterns. And later on, we will talk about viewing behavior. And further, we would like to know the difference of viewing patterns between pass and fail. We use the same the MCA. So this is the MCA, and this is the patterns, their behavior, and types of learners. So we can classify for these high-performance students. For example, their behavior is a confirmation of concept and seek focus. Then it probably is a comprehensive learners. But this is by experience and by observation. And also it's for students who repeated confirmation, then they probably is a reflective learners. And for students who move forward, seek focus, and probably is a target learners. All the 3 types of learners, they pass the course. So we further would like to use the LSA to find the difference of viewing pattern between pass and fail. Okay, this is the behavioral transfer diagram. So students who pass, for all the red lines indicate it is significant for pass. So this is the students, their behavior for who pass. So we sequence this score following the same way, and this is their behavior and this is their type. Here is the corresponding video clip, so I won't go to details. This is the same thing, how we identify students are reflective learners. And this is target learner. For students who fail, they also have some behaviors which is significant, different from the others. So we identify 3. And for this kind of students, we call it surfing because they continue to skip all the videos. So no wonder they get a low grade. So we finally classify 4 types of learners in our class, in Calculus 101. And we apply these experiences to other courses. Right now I only dedicated to this course. So there are 4 types of learners. in this, we are continuing working on is with knowing the viewing patterns, how to improve academic with timely intervention. And also here is the intervention, what is our so-called timely interventions. So we would like to follow hierarchy's approach, have a recommendation systems, for example, book roll plus Kuronai, right? Am I pronounced correct? Dr. Nishioka, okay? Okay, thank you very much, okay. I try very hard to pronounce it correct. Okay, here comes our study 4. We do clustering analysis. As I mentioned, most of the course, we don't know their grade. So the way we can do is do clustering analysis. This is why we have to, because their grades are not available. So still based on the top 10 course, we choose the number 1. And this is the k-means we use. We choose the elbow method. Here is the features we implement. We classify, you can classify many, but with the k-mean elbows, it happens to be 6. So we take a look at from the 6 clusters. For this cluster, there's only 1 person. It probably be outlier. For here, 18 person, not many, but we should look at it. So here is how we, based on the number of activity per learners, we found so cluster 2 is the most active and decreasing. So this is the description. So extremely high actives is probably outliers. Here's the, we use the diagrams. A different color means represent different clusters. So in here we have 6 colors. So for the cluster 2 is orange. You can see it's orange lines is outperform the other clusters. So which means it's much activity than the others. But there is only 1 person. So this could be, and very possible it is outlier. For example, it could be a TA. So after we remove the cluster 2, so the orange gone, now we have 5 clusters left. So we can compare the 5 clusters instead of 6. And right now, the most better performance is the blue one. Blue one is cluster 5. It's comprehensive because it still have much more activities than the rest of clusters. And there are 18 students, reasonable, okay. And here it comes to the reflective, based on our previous presentation, it said so on and so forth. So 6 is more backward activity than the rest. And C1 is more forward activity than the rest. And for the surfing, the activity, average activity per semester less than 1. It's very little activities. So we just classify it into a surfing. So this is what we are going to do. We try to encourage our instructors to implement different learning strategies, especially its self-regulated learning, and try to improve it with SRL. So this comes to my second part of presentation, which is prediction at risk students. Here is at risk means students could be fail or could withdraw, or they just perform not so well. They could get score, low score and low grade. This is the so-called at-risk students. We use machine learning. So before, I think lots of research machine learning, we just utilize those machine learnings for our prediction. For classification, if we just want to a discrete, so it's a pass and fail, yes or no, then we can use classification. But for some linear scores or grade, then we have to use the regression. Here are some examples of classification and some of the regression examples. We will compare here. There are 6 algorithms, so we're going to compare the 6 algorithms. Of course, you can compare any other 6 or any other numbers of algorithms. We just try to find out which algorithm is most suitable. So here comes our final study I'm going to present today. Can we do early prediction, not just prediction, but as early as possible, of students' academic performance in a blended learning. So here is what we ask. the questions is, compare the 6 regression algorithms. Which one is the best algorithms for predicting students' performance? And how to improve the performance of prediction? And finally, can we do early prediction and how early it is? So here comes. As we still use the calculus 101. And for regression, most of the time we use PMSE, P predictive mean square error. Also, you can use other, but in this study, we only use this one. So compare the 6 algorithms. PCR perform the best. PCR means MLR plus PCA. So can we improve the performance of prediction? Yes. In general, you can use a full set or subset. So we try to use a subset to improve the performance. And also we have to remove outliers. For example, TA, the record should be removed. So we break our data set into, in Taiwan, there are 18 weeks. So we can break 18 weeks into, for example, for the first 6 weeks, it means 1/3 of the weeks. So can we predict as early as 1/3 of a week? That's our first question. So here is the comparison. So for 1/3, 1 to 6 week, 1/3 of the semesters, the performance is here. For the whole semester, 18 weeks, the performance is here. Relatively the same, but anyway, still, week 1 to 6, still a little bit outperform week 1 to 18. And we further compare is which one is more stable. So use the box plot. Week 1 to 6 is more stable than 1 to 18 because there is an outlier here. So next question is we should remove those outliers. So the method we use, there are lots of methods. I just mentioned one of them. We can use Cook's distance with defeats. So the performance is still much better, relatively better than the original one. So here is the conclusion of these studies. If we use data set with 1 to 6 weeks, and we use PCA, so we have the component, 12 component out of 29 features, and we can predict as early as 6 weeks. So once we know the student who probably get fail or get low scores, what can we do? We should provide recommendation, right? So this is what we're going to do. We apply CNN, convolutional neural network, for classification, especially for small samples. You have to use this neural network and then follow a recommendation based on concept map. And our next work is try to find out the portability of the prediction. Because right now, we have experiences of prediction in calculus. How can we transfer these experiences to other courses? That's what we are interested, especially for computer science or other courses. Here is the trend of transfer learning. So for traditional supervised learning, still very hot. For the transfer learning, it's getting hotter and hotter. And for reinforcement, this one is done Andrew Ng. Okay, so what that based on his saying. So transfer learning is quite a rising star. So we will put our emphasis on transfer learning in our future research. We would like to know the transfer learning between different data sets. Okay, if for the calculus domains, how about it between different college, and a different department, or even college and high schools, and between different learning media? For example, can we transfer experiences from video to ebook or vice versa? This is kind of a transfer learning is going to do. We also would like to do transfer learning from source domain to target domain. It's even more challenges. From different domain, our experiences in calculus, transfer it to CS is quite a challenge. So enjoy your Sakura season here. Thank you very much.